So now we're going to look at a real world situation involving rate of change. So we've got some values in a table, and the height of a soccer ball punted in the air from a height of 1 meter, that's the initial height, was tracked using time-lapse photography. Donovan, an aspiring sports scientist, recorded the heights of the ball at half-second intervals, and his results are shown below. So first they want you to just calculate the average rate of change. So literally from this table, you're going to do y2 minus y1 over x2 minus x1. So you're going to grab your x's and y's and you should be able to find those rates of change because that's just slope. So if this was a straight line, slope of a line. In this case, it's a curve. It's still the rate of change. So if I do the first one with you and then you can do B and C on your own, my y value I'm looking at 0, 1, 0 seconds, and 1, 14.1. So I'm going to do 14.1 minus 1 in the numerator and 1 second minus 0 seconds. So y2 minus y1 over x2 minus x1. So that gives me a rate of change of 13.1 meters per second. So all I did was subtract, and then I'm dividing by 1. So make sure when you divide, you're putting parentheses around the numerator and denominator if you are using the calculator. So I'd like you to finish 1, B, and C. So you can pause the video and try that before moving on. Then we're going to do a scatter plot of the data. I'm actually going to skip that step and just do it for you on the graphing calculator. So if you have a graphing calculator, you can follow along. You'll want this function anyway to finish this on your own. So stat edit, and you can use the graphing calculator on your Chromebook, or come get one from me during Flex or virtual and just use it in the hallway. But on Google Classroom at the top, under classwork, there's a place where you can download the calculator extension if you still don't have that. So you're going to enter the x values and the y values. So I'm going up to 3.5, and then 1, 8.8, 14.1, 17, 17.4, 15.4, 10.9, and 4. So to view the scatter plot, you have to go to second stat plot and turn on plot 1, and then hit zoom. Zoom stat is number 9, invalid dimension. Oops. Let me get rid of what I have in my y equals menu and try again. Zoom 9, invalid dimension. What is wrong with this? Stat edit. 0, 1, 1/2, 8.8, 1, 14.1, 1.5, 17, 2, 2.5, 15.4, 3. Oh, let me go back to second stat plot. Oh, so I have list 1 and list 3 right there. So I need to make sure I'm reading list 2. So second 2 to change that to list 2. Now I can do zoom stat. So this is a quadratic function, right? So you can skip graphing it. So I did that part, right? It kind of looks like this. So on calculator, right? So there's my quadratic. So it says what parent function? We already said quadratic. So now find the regression equation, and it gives you the steps, but you just go to stat calculate, and we want to do a quadratic regression choice 5. And I'd like to store the regression equation in my y equals. So that's under vars, y vars, function, y1, calculate. So here's my equation. I'm going to record it below. Y equals negative 4.9x squared plus 18x plus 1.008. But you've got the full equation in your y equals menu. So now let's answer some questions. Use your regression equation to estimate each of the following: the maximum height of the ball, the time when the ball reaches its maximum height. Isn't this just the vertex? And the time that the ball lands is just the x-intercept, right? So on my graph, now it's going to graph the function on top of the scatter plot because I stored it in the y equals menu. I'm going to calculate the vertex of that quadratic. So that would be under second calculate maximum. and I want to make sure that my cursor is to the left of the maximum, hit enter. Now I want to make sure I'm to the right of the maximum, hit enter, and then take a guess where you think the maximum is and hit enter. So it's telling me the maximum is at 1.84. So that's the time, 1.84 seconds. The height is 17.54. This was in meters. So I'm just writing down my answers. The whole point of this was to teach you rate of change. So we're reviewing some of the technology stuff, but this isn't rate of change. This is finding pieces off a graph. All right, the time that the ball lands, I want to find this intercept. So this 0. Second, calculate 0. And I'm going to go to the left of the x-intercept. I'm arrowing over, still arrowing over. Okay, I'm on the left, hit enter. Then I go below it to the right, hit enter. Back up to the x-intercept, hit enter. It lands at 3.73 seconds, it says. 3.73 seconds. So now I can use this to answer the questions down below. So we're going to try instantaneous velocity. How fast is the ball going? Instantaneous rate of change. So I'm going to do a couple of these with you, or at least figure out the coordinates, and then you can finish calculating what they are. 0.1 seconds after it was kicked. You want to go 0.01 on either side of 0.1. So my first point would be at 0.09 seconds, find the height, and at 0.11 seconds, find the height. So now that I have it in my y equals menu, I'm going to go to second table setup. I'm going to go to 0.1, and I'm going to count by 0.01 in my table. Then go to second table. So now I can grab those 2 points. So at 0.09, I'm at 2.5889. And at 0.11, I'm at 2.9293. So now I'm going to do the rate of change between those 2 points. 2.9293 minus 2.5889 over 0.02. Because 0.11 minus 0.09 is 0.02. So I'm going to calculate that. 2.9293 minus 2.5889. I didn't use parentheses. I'm just going to hit enter first and then divide by 0.02. So it's going at 17.02 meters per second as its instantaneous velocity when it was kicked. What about at 1 second after it was kicked? So the points you're going to want to grab this time are 0.99 seconds and 1.01 seconds, and then do the slope between those 2 points. What about the time it reached its apex? The time we got up here was 1.84. It reached the vertex. So you're going to go to 1.83, see what you get, 1.85, see what you get. That will give you the instantaneous velocity at 1.84, because that's directly in between those 2 closely related points. The time just before it landed, if it landed at 3.73, let's go back to 3.72. So if we want instantaneous at 3.72, we're going to do 3.71 and 3.73. So I did A with you. I would like you to pause the video and try B, and then unpause the video and make sure you got it right. And then you're going to complete C and D on your own. So pause the video now before I complete part B. Now I'm going to complete part B. Table setup, I'm going to go to 1 second, 0.01 on either side, second table. So I'm going to grab at 0.99, it was at 14.028, 1.01, 14.192. So I'm going to do 14.192 minus 14.028, hit enter and divide by 0.02. 8.2 meters per second is my answer to part B. So did you get the same thing? Hopefully. So you're going to try C and D. So what you need to submit for today is those 2 pages, really just this page because I wanted to see that you did 1, B, and C, and this page because I wanted to see that you did 6, C, and D.